I think a new relationship between people and machines will drive architecture in space. You're familiar with Corbus's quotation that says, "The house is a machine for living." In space, it really is a machine for living. And if the machine breaks down, life is not possible. You can't just open the window and get some fresh air. But especially when we get to remote planetary locations, the routine operations will inevitably be mediated by machines. There will be a lot of tedious, perhaps dangerous, boring work that should be done by robots in the future, not by people. The best use of humans is to figure out what's going on, to decide where to explore, how to make things, fix things. That's what humans do best. By the way, on the moon, you have 2 weeks of day and 2 weeks of night in most locations. 2 weeks of night is a fantastic opportunity to take equipment inside, take it apart, repair it, and get it ready to put back out for the next day. But this will be driven by economics. This is not just a desirement of the way the future should be. We will be forced, because of the enormous expense of crew time, to put the routine operations in the hands, so to speak, of machines. And I think it's easy for us to anticipate that 20, 30, 40 years from now, the kind of robotics we will have is even more advanced than what we're seeing come into mainstream use on Earth today, so it's reasonable to expect this. So one of the things that's also never really been done in space architecture, but will have to be done, is to develop shirt sleeve, that is, inside module, not exterior, workshops. These modules have been designed as laboratories with very expensive analytical equipment for doing fundamental science, but nobody has developed a module, the purpose of which is to build things, take things apart, and actually experiment the way you would in your workshop or your garage or your basement. And here's my final one. The humans, ourselves, animals, plants, and microorganisms of the year 2030 will not be the same as what we have now. So here's a quiz. I was born in 1958, the same year as NASA. So I grew up in the 60s with Star Trek and 2001. And if I had taken this quiz back then, when I was a kid, I would have flunked. And I bet you all would have too. Some of the things on this list were either not even imagined back then, or if they were imagined, would have been rejected as unfeasible or unlikely to happen. So taking mice and developing strains of mice in which genes have been added or deleted for research purposes, that's the first one. Using DNA fingerprinting as admissible legal evidence in court cases. Cloning pets. Who would have imagined cloning pets? That's like a science fiction idea. And then a moon base. We all knew in 1968 that a moon base was the one that was going to win. And yet here we are and we still don't have one. But we do have the other three. So my point is to question what biological miracles will be common 30 years, 20 years from now. The things on this list were not even imagined, most of them in the mid-60s, and yet they are in practice today. So this is a caution that when we project the future, we tend to do it as a linear extrapolation of what we know. Yet the world marches on. In the 60s, the frontier was space. Today, the frontiers are genetic engineering and nanotechnology and information engineering. So it's not unreasonable to imagine that within a couple of decades, the time frame of lunar exploration, exploring near-Earth objects, and these other things I've talked about, that the plants and animals we take with us, that therefore we're designing the architecture to accommodate, the utilization of which, in fact, is part of the architectural design, these things will be optimized, these living things will be optimized for those conditions. They will not simply be what we have on Earth and take with us. So all these environmental conditions I list here are ones which we can design biology to accommodate, including eventually ourselves. That's something to think about. We will design ecologies to meet our needs. Okay, so my final point, something I'd like to leave you with, maybe stimulate discussion, is this simple matrix. Down the left, you see a hierarchy of topics having to do with human activity and human living. Ergonomics is, as you know, the science and practice of designing things to be used, how a pen works or how a glass works, how a desk works, and those kinds of things. The biological topic are the ones that have to do with life support and sustaining life, keeping it going. Psychology for space environment has to do with the mental health and ability to function and be happy in such a remote and hostile and weird environment. And then sociology is the same thing but applied to the interaction among multiple people. And as groups of people, as size of groups of people in space increases, the sociological aspect becomes more and more critical. So that's a hierarchy of topics, and they're matrixed here against types of populations in space. To date, every population in space has been a mission crew. And so you see, we know lots about the ergonomics of mission crews in space. We have since the early 60s, or we've been learning since the early 60s. And we know something about the biology and psychology of people in space, when they're highly trained and there for a specific purpose and professionals. We know absolutely nothing about any of these things for passengers. That means ordinary, untrained people. And we know even less than nothing, if that's possible, about settlers, the people who someday will go to these places and not come back, and have children and raise families and create civilization in these remote places. So for those who are architects or designers or interested in the human condition and its interrelationship with the physical environment, when you contemplate space architecture, it's an open field. So I wouldn't want you to see what's been done and see what is being done in NASA and other agencies and think, oh, there's nothing left to do. We know everything about it. We know far from everything about it. There's ample opportunity to stimulate young minds for many, many decades. With that, I'll leave you and on to the next topic. Thank you.